Hi guys. Okay, so we are doing linear inequalities day 2. So what that means is if you have not watched the day 1 video, you need to stop this and go rewatch or go watch the day 1, linear inequalities day 1. So the stuff that we learned for day 1 is still going to apply today. So we need to know whether a line should be solid or dashed. We need to know if we should shade above or below. All that stuff is still being used today, okay? But there's a few things that I want to cover. So go ahead and in your notebook, let's call this section graph and find possible solutions. So just a reminder, if we are trying to solve a linear inequality with two variables, x and y, the only way to really solve that is to graph it. And then the shaded area is all your possible solutions. Okay, so in the last video lesson, all of the equations, keep doing that, not equations, all of the inequalities that were given to you were already in slope-intercept form. So it made it really easy to kind of graph. Plot the y-intercept, slope tells you how to move, right? So the ones that you're seeing today are not going to be in slope-intercept form to begin with. So that's kind of our first task. So let me show you, here you go. Here's your linear equation. X plus 2y is greater than or equal to -4. X plus 2y is greater than or equal to -4. Now we are going to put a graph off to the side, so leave the space for that. But this right here is not in slope-intercept form. I personally like to graph from slope-intercept form. If you remember from a week or two ago, 2 weeks ago, I did teach you how to graph standard form using the y-intercept and x-intercept trick. If you're comfortable with that, you can do the x and y-intercept trick to graph it, but I will just warn you that they don't always end up as nice whole numbers. So that's why I personally would rather change it to slope-intercept form and then graph it like normal. Okay, so that's what I'm going to be doing today. So off to the side, you're just going to tell yourself to convert. If you don't like that word, you can write change. Convert to slope-intercept form. So that's going to be our first step here. So if I want this to be slope-intercept form, my y needs to be isolated on the left. Okay, we've practiced this before. So your first move is to get rid of this x and essentially move it to the other side. So to get rid of that positive x, I would have to subtract x so that it cancels to nothing. But we got to remember, whatever you do to one side, you have to do to the other. So you do need to subtract x on the right-hand side as well. So my x's cancel out. I'm left with a positive 2y is greater than or equal. And then right here, we got to be super smart about this. -4 minus x. You cannot put those together. They are not like terms. So you can write it as -4 minus x. I recommend putting your x term first because we want it in that form anyway. So I'm going to put the -x right here and then drop down the -4. So right now I have 2y is greater than or equal to -x minus 4. Okay, last thing to do to get y isolated is to get rid of this 2. We need to remember that 2 is timesing by y. When they're squished right together, that means they're multiplying. So we divide by 2 in order to get rid of it, because 2 divided by 2 is 1, and 1y is just y. Okay, but here's another thing that we have to remember. Whatever I do on one side, I have to do to the other, right? So you could do one giant fraction bar and dividing both of these by 2. But since both of those terms have to divide by 2 anyway, I like to just give themselves their own little fraction bars, okay? So let's go ahead. Negative x divided by 2. Well, I want you to remember that there's secretly a 1 right there. So you basically have negative 1 over 2 and then x. And negative half cannot simplify any further. So we drop it down as negative 1/2 x. And then we simplify this. Negative 4 divided by 2 is negative 2. So here is my inequality written in slope-intercept form. So the reason why we converted, guys, is just so that it's really easy for us to graph it. Okay, so off to the side, you're going to draw an XY coordinate grid. Definitely need to make sure you can go down to -2 on the y-axis, since that's where our y-intercept is at. So go ahead and set up a little graph. Pause the video if you need more time. Okay, so to graph this, I start with the y-intercept, the b value, which in this case is -2. So I plot my y-intercept at -2 on the y-axis, and then the slope is going to tell me how to move. Okay, so the slope is -1/2. So it's definitely going to be a line like this. It's going to be descending. Since it's negative, I'm going to go down 1 and then right 2. Now, we can also go upwards in this direction. So instead of going down 1, right 2, you can do the opposite of that and go up 1, left 2. That just shows you a little bit more on the graph, which is a good thing. Okay, so now I get my ruler, you know, something close to me with a straight edge, but the question remains, do I do a solid line or a dashed line? Because that matters. So I might go back right here and remind myself of 2 things, solid or dashed, and then shade above or below. So that's all based off of this symbol. This is a greater than or equal. Because it has that little or equal to part, it's going to be a solid line. Solid lines mean that anything on that line is a solution. So those points that we graphed, those are possible solutions because they can be equal to that line. Okay. And then the other thing that this symbol tells us, because it's greater than, tells us to shade above. Greater than, shade up. Okay. So if you want to write up or above, whatever. Okay. So then you would go ahead and you would shade above this line. Solid line shaded above. Okay. So that's something we're practicing today, is if you're given an inequality that's not already in slope-intercept form, just reminding you how to convert it and all that. Okay. So number 2, here you go, 9x minus 3y is greater than 6. 9x minus 3y is greater than 6. Okay, so I'm going to convert this to slope-intercept form. Here we go. Get rid of the 9x. So I subtract 9x on both sides. And then here you need to be very, very careful. When you drop down this 3y, it's a negative 3y. Gotta keep that negative with it. Drop down my symbol, and then 6 minus 9x, you can write it as 6 minus 9x. I put my x term first, which would result in negative 9x plus 6. Okay, so I've moved my x over, but now I need to get y completely by itself. So I'm going to divide by whatever's attached to it. Now, I'm hoping you can kind of fill in the blank here. Way back in, I want to say November, we did inequalities, less than and greater than signs. And a rule for inequalities is, let's see if you can fill in the blank. If you multiply or divide by a negative, you have to flip the sign. So hopefully you kind of remember that. And this is for inequalities. If you multiply or divide by a negative, you have to flip the sign. Okay. So right here, I'm telling you this because what are we going to end up dividing by? We divide by -3 on all of these terms. And because you divided by a negative, you have to switch around that sign. So that now becomes a less than symbol. Okay, so I think it would be good for you right now is to make that a reminder off to the side. If you multiply or divide by a negative, switch the sign. Let's say switch the sign, flip the symbol, whatever makes sense to you. Okay, very important for us to remember that, because what would happen is if I don't flip the sign, if I were to forget that, then the shading would be off, which means all my possible solutions would be wrong. Okay, so that's something we really, really got to remember. Okay, so we're going to divide every term by -3. I already switched the sign for us. So now let's simplify. -3 over -3 cancels to 1, which is just 1y. -9 divided by -3 is +3. Don't forget your x. 6 divided by -3 is -2. So final inequality in slope-intercept form is y is less than 3x minus 2. So before we graph this, let's tell ourselves those two things. Solid or dashed and above and below. Try to do it without me. If you're forgetting what symbol that is, use my little L trick. Less than, it's a tilted L. That's a less than symbol. So less than means it's going to be lower or below. It's shaded below. And because it doesn't have the equal sign, means it can't be a solid line. It has to be dashed. Okay, so now let's set up our graph. Okay, so start at your y-intercept, which is at -2 on the y-axis. So 0, -2. And then slope is 3. And remember, that's rise and run. So we need to think of it as like 3 over 1. So that means up 3, 1, 2, 3. And then, did I count right? 1, 2, 3. And then right 1. Up 3, right 1. Okay, and you could technically, if you had room, I don't have room, you could go down 3 and left 1. That would still be in a line. So I take my ruler or whatever next to me that has a straight edge, and I go, wait, not solid. I can't do a solid line. So this is where you do your little dashed line. Okay, so that's kind of your boundary line. So the points on there are not solutions, but in the shaded area, which is below the line, so this way, anything that way of the line is a possible solution. Okay, forgot to mention possible solutions. Like up here, if you wanted to, you could write like 1, 1. You could do -2, 2 as 1. Also right here, like 0, -2. That was a point on the line. That one is a solution because it's a solid line. Here, we could not say that 1, 1 is a solution because it's a dashed line. Okay, but like 2, 0 and -1, what would this be? You could do even something crazy, 1, -10. It's not on there, but it would be in the shaded zone. Okay. Okay, and then there's 2 more types of graph that I want us to put in here. So I'm going to do 3 and 4. There's not any converting to be done. You just have to remember how to graph things that look like this. So let's say I have x is less than 5, or y is greater than or equal to -2. Those are like short, right? But they are going to be linear inequalities. So we need to know how to graph them. These are your horizontal and vertical lines, and you need to know which one's which. So this is where I would think about Hoy-Vux, Hoyvux. Because this is an x inequality, it's going to be a V. It's going to be a vertical line. So when we graph it, it's going to be a vertical line. Where is it going to go through on the x-axis? It's going to go through 5 on the x-axis. So let's go ahead and draw that. And these can just be kind of like sketch graphs, you know, not super exact. That's fine. So I'm going to call that 5 right here. So we have a vertical line going through 5 on the x-axis. Should I do a solid line or dashed line? Dashed. It's not equal to. So you need a dashed line at +5 going through the x-axis, vertical line going through the x-axis at +5. It's dashed, and then we do have to shade because we have to show all the possible solutions. So this says x is less than 5. So which way do you think? We got 2 options, left or right. So there's no above and below for a vertical line. Left or right? Well, it's less than, so it's still left. So anything over there in that zone would be a possible solution. So like right here would be like, you know, -2, 2, that would be a possible solution. Down here, -1, -5, that's a possible solution. Okay. And then question number 4 says y is greater than or equal to -2. Well, if it's a y equation or inequality, we would use HOY, H-O-Y. That's to remind you that it's a horizontal line, it has a slope of 0, and it's written as y equals or y, and then your symbol. Okay, so horizontal line going through where? Well, it's going through -2 on the y-axis. Okay, so you need to go ahead and draw a horizontal line going through -2 on the y-axis. I forgot to mention that, yes, this is solid because it has the or equal to. Okay, so solid line, and then we just have to remember how to shade. So this is going to be above or below. Because it's greater, you would shade above. Okay, so some possible solutions. You could have a point on the line be a solution because it says it can be equal to this line. So right here, if this was like 3, -2, that's a solution. You could go up here to -1, 3, that's a solution. Okay. Okay, so main thing on this page, switch it to slope intercept form. If you divide by negative, flip the sign. Okay. Last part of notes, I just want to do a couple converting problems just so that you're experts on it. Okay. So converting practice. Okay. So we're not going to graph. We'll just practice converting. This is number 5. Okay, number 5, 3x plus 5y is less than or equal to -10. If you're feeling confident, I'd go ahead and hit pause and then hit play when you want to check your answer. So I want this in slope intercept form. That means the y is going to be isolated on the left. So the first thing I get rid of is this 3x. So I'm going to subtract 3x on both sides. 3x's cancel out. I'm left with positive 5y is less than or equal to. And then this is where like, these are not like terms, so you can't put them together. So I'm going to put my x term right here. The constant or the regular number is going to be at the back. Okay, and to isolate y completely, we divide by whatever's attached to it. I got to divide all of this stuff on the right side by 5 as well. So basically makes 2 little division problems since there's 2 terms over there. 5 divided by 5 is 1, so I'm left with 1y. -3 over 5, you can't simplify that further, so you just leave it as -3/5 x. -10 over 5 is -2. Final answer, y is less than or equal to -3/5 x minus 2. A good thing to just kind of walk through in your head, even though we're not graphing right now, is think about solid or dashed, shade above or below, because that's something you kind of just got to know, right? So this one would be a solid line because it can be equal to the values on the line, and it would be shaded below because it says less than. Okay, number 4, or not number 4, 6. 8x minus y is greater than 5. Please pause the video, try it out, play it when you're ready to check. Okay, so routine is the same. We get rid of our x term, so I subtract 8x on both sides. That leaves me with a negative y is greater than negative 8x plus 5. And then it looks like I'm almost done, but I'm not. I don't want a negative y variable. I want positive y. So we remember that there's a 1 there. So we divide every single thing by -1. There should be an alarm going off in your head. If you multiply or divide by a negative, you have to switch that sign. So sign gets switched on this one. We're left with positive y is less than 8x minus 5. Okay. Do one more together. And then number 8 will be your one to practice for entry test. Here you go. X plus 4y is greater than or equal to 12. Pause the video, hit play when you're ready to check. So we subtract x on both sides, left with 4y is greater than or equal to negative x plus 12. To get y by itself, I divide every single term by positive 4. Do I switch the sign? No, I do not, because we divided by positive. We're fine, we're cool. Y is greater than or equal to, and then I'm hoping you remember what we do right here. There's a little secret 1 there. So this is negative 1 over 4. We just leave that as a fraction, negative 1/4. 12 divided by 4 is 3. Final answer, y is greater than or equal to negative 1/4 x plus 3. Okay, number 8. This is for your entry test to plug in. 10x minus 5y is less than 15. There you go. Put that into slope and form, pretty please. Okay, I'm gonna do a few problems on delta with you, and then that will be the end of the video. Okay, so delta math, it's gonna have some graphing. But if it's in standard form, or basically any form but linear or slope-intercept form, then you're going to want to convert it. I would recommend. If you want to try out the x and y intercept thing, then that works too. This one would not be a great one to do for that. Anyways, so I recommend off to the side working out this problem. So I would copy it down. 2x plus 5y is less than or equal to negative 5. So I start by getting rid of the 2x on both sides. Leaves me with 5y is less than or equal to negative 2x minus 5. Divide every single term by a positive 5. So I don't need to flip the sign here. And I'm left with y is less than or equal to negative 2/5 x minus 1. So you would get a scratch piece of paper and you would convert it onto the side. Okay, so then to graph this, my intercept is -1. So we go to -1 on the y-axis. The slope is negative 2/5. So that means we're going down and to the right. So down 2, right 5. And then this is where it pops up with the change line and change shade. So you need to look at your symbol here, which is a less than or equal to. Since it has the equal to, you would leave it as solid. And then shade up or down. Well, look at the symbol. It says less than. So that means lower, shade lower. And then I hit submit. Boom, check mark. If you get these wrong, you can always read through the explanation just to see where your error's at. Okay. And then if it gives you a problem that's already done for you, then cool, that's awesome. -4, slope is -1, down 1, right 1. This would be a solid line and we would be shading below. So some of them you won't have to do work off to the side. Okay, this one you would need to subtract x, divide everything by 3, and then go ahead and graph it. Okay, okay, that's it. Have a wonderful day.